We're here at Sydney Dragway with what has to be one of the cleanest, tidiest Evo drag builds that I've seen. We're here with Jimmy from ERS to find out a little bit more about it. So Jimmy, it's hard to know if this is a show car or a drag car. Talk us through the sort of idea behind the build.
Well, it's actually a street car, but yeah,
Sydney street car.
Sydney street car. So yeah, it's a drag, roll racing, street car. Bit of everything, you know. It's got all of it, all the package. But yeah, man, it's all in one.
Let's start with the intention behind the car. Obviously, if you want to keep something streetable, the legality side of things is one element.
Yep.
And then you've got two very different disciplines with some crossover with roll racing and drag racing. So can you talk to us about the sort of the idea behind the parts chosen and how that works for this build?
Yeah. So obviously the intention from the owner, when he approached us to build this car, it was already a bit of a show car. He loves all the show, you know, the spec look of the back in the days, auto salon days. And then we wanted to mix it up with, you know, presenting it to 2022, you know, make it look good, tough, and also perform well. And then we turned it up from there halfway through the build where he goes, "No, I want to break records," you know? So we're like, okay, we'll do whatever it takes to break records. And obviously all the brains behind us working hard on the circuit, building drag cars before, and you know what's out now, the technology out now, we said, look, let's just implement it all into the same car.
I mean, obviously technology has come a long way in the last decade or so, certainly between the times when I was back drag racing and now it's gotten a lot easier to make power. You've got better engine components, you've got billet blocks and everything. Is it suffice to say, though, there's some compromises in a build when you want to keep the car looking as good as it does? I mean, you look at that interior, it's not stripped out. It is a work of art.
Yeah,
clearly, for nothing else, it's going to be heavier than a stripped out interior.
Yeah, we tried to find the balance between obviously looking awesome, not gaining too much weight, trying to lose weight, but also keeping a full interior for the fact of, you know, it's a street car, it's comfortable to drive, you can drive it anywhere, and you can. Like I drove it yesterday, you know, to the track, drove it back home. But yeah, man, we tried hard to, it's got a full cage for the safety, because that was the most important thing for the owner. Look, safety comes first. It's got a parachute, it's got everything ready to set up to break records. And the car's got two different looks as well. Like we've got a set of drag wheels, we've got a different bonnet, we've got an exhaust out of the bonnet once we go for a time. And then we've got the street, you know, sort of, as you said, legality setup where you can drive it with street tires and stuff. Yeah.
All right. Let's just talk about that wheel package. I mean, it's a little off trajectory, but let's just cover that, seeing as you mentioned. At the moment, it's sitting on a set of 18-inch SSRs, and that's going to be great for driving on the street, but not ideal when you want to go drag racing. It's difficult though, because the go-to combination for drag racing is a 15-inch wheel, opens up your options for a proper drag tyre. You can't really fit that over stock Mitsubishi Evo brakes. So what have you done there to allow that 15-inch wheel to fit?
Yeah, so one thing that I get asked about all the time, especially in the workshop, is from customers is, you know, I want to lighten my car. I say to them, okay, lighten the rotational mass items first, you know, wheels, wheel studs, wheel nuts, you know, try to go to a smaller rim, obviously if it's drag, you know, a lighter tire, brakes, anything that's spinning, right? Tail shaft, stuff like that. So we've got the SSRs are just there for looks, you know, maybe roll racing, whatever. We've got the 15-inch belak wheels, which are a proper drag wheel, and we've got a nice fat Hoosier 275 tire, which Hoosier has been awesome with the car. They've helped us out heaps. And yeah, we've got titanium wheel studs, we've got titanium wheel nuts, we've got Wheelwood. This car's got titanium through everything. I went all out. I said to the owner, I said, look, leave the titanium stuff to me. All the bolts and nuts and everything, we tried to go titanium. And we've got Wheelwood brake kit on it. So we'll see how that goes. We're a bit worried there, but we've got parachute anyway. So yeah, 15-inch wheel, small Wheelwood brake kit. And we can go with an RS non-Brembo front caliper if we needed to. So.
And the benefit, of course, with drag racing is that, while yes, you're going to be stopping from high speed, you've got that parachute, as you mentioned, and you only have to stop once. So there's not a lot of
heat.
heat to dissipate out of that brake package. Okay, let's get to the exciting part, though, which is obviously the engine combination. These days, billet has sort of become the go-to option for anyone serious about drag racing. It looks like this is no different.
Yeah, so this has got a bullet 4G63. A lot of big drag cars go to the 64. I opted for the 63 just to keep it original. I love the 4G63, setup. So we worked closely with Micks Motorsport. Micks Motorsport's got his engine package in this. We've obviously worked together with him on what sort of specs we're going to put cams, rod combos and whatnot. So we worked together on that to make the best decision for this car. And yeah, it's got a non-MIVEC head. So we decided it's better to just get away from the MIVEC for now. Firing, gasket setup, alloy rods, custom pistons.
Let's just go over a few of those elements that you've just discussed in a bit more detail. So for a start, 63 versus the 64 block. The 4G64 is a 2.4 with a factory 100mm stroke. The 63 is 88mm stroke 2 litre. And quite often people will go to the 64 route for that extra capacity. Obviously, 2.4 versus 2 litre, it's a reasonably big difference. But the downside is with that 100mm stroke, it tends to hurt the ability of the engine to rev. So is that why you stuck with the 63 block?
Well, that's one thing. Obviously, the 64 has a bit of a taller deck. So if we ever wanted to just put a cast block in as a spare motor or whatnot, at least it's all the same heights and everything.
So all your fabrication will work with a factory 63 block?
100%. So we wanted to keep it, not complicate it too much. Obviously, the car is very high end, but we didn't want to complicate that part in case we needed to try something. Also, like the 64 100mm crank, I love it. Like my car is a 2.3 litre. I love the stroke, but for obviously big power, more harmonics, all of that stuff. Revs as well. Yes, we love the torque from the 64 2.4, but it's trying to find that balance between.
Very different applications. I mean, your car, which we've interviewed you about and previously, is for circuit racing, and that bottom end response is important. And I'm guessing you're probably not revving to 10.5, 11,000 RPM either. So that's where the 100mm stroke doesn't really work well.
That's correct. Yeah, so it's got a 94mm crank. So just to get that revs, 100mm stroke, again, at 9, 10,000 RPM, it's too much.
Yeah, and the 2.2 kit that you get with that 94mm stroke, that's kind of my sweet spot as well. It gives the extra capacity, but still doesn't really hurt the ability of the engine to rev. And you mentioned alloy rod as well?
Yes, alloy rod, a custom piston. The alloy rods were something that we decided to do, me and Mick, just for obviously application. And again, like what you said before, obviously we're very young compared to the guys that were racing 20, 30 years ago. But I think technology's come a long way from what I understand on servicing alloy rods and bearings and all that. And
the alloy rods definitely got some advantages. The downside is that they do tend to fatigue over time, so they don't have the service life of a steel rod. But for a car that's not going to be running sort of 10 passes at the drag strip every weekend, that's probably not necessarily a huge issue. I want to come back to that head gasket because this is always the weak link for any turbocharged drag engine in terms of how much boost you can physically cram into the engine and keep the head gasket sealing. So you mentioned a fire ring. Can you elaborate a little bit on what that term actually means?
So firing is the seal around the cylinder. There's different combinations from what I understand, but the common firing that we use obviously in Sydney is copper head gasket, sealer, firing, and just send it with boost.
Knowing Mick, and I've bought parts from him in the past, it'll probably be the aluminium bronze sealing ring. That seems to be the way, and has sort of become the go-to standard across Pro Mod plus just about any really high output turbocharged engine. So the bottom end really is kind of there just to support the power in and of itself. It's not really sort of doing much other than hopefully holding together. The head and the turbocharger is really the sort of the key to the whole combination. You mentioned a non-MIVEC head. Are there any compromises in terms of cam profile to keep the thing somewhat streetable?
Yes, like we obviously tried to go a big cam, not too big on the exhaust, big on the intake. sorry, opposite way, exhaust bigger than the intake, just to get the air out. But obviously, keep it streetable. It's very nice, very lumpy, which what the owner wanted. But yeah, so we went away from the MIVEC, even though I love MIVEC and I wanted to keep the MIVEC, but we just had that bit of worry of breaking the cam, which has happened on another car that was making like 1100 horsepower. It's actually the owner's other car. And we just wanted to, it's not in the application for it. It's good for the circuit. We've got it in our circuit car. This is, again, different application.
Generally as well, the downside with any variable valve timing mechanism is that it does tend to limit how big a cam profile you can physically fit in there. Plus, when you're looking at a rev range out to 11,000, the benefits of the variable cam timing tend to go out the window to a degree as well. So I think it'd be a pretty standard setup for something of this nature. Turbocharger, what are you running there?
So we've got a Precision 8085. And which the guys at PRP helped us out with that. They're the main dealers for them. It's a next gen. We're going to push it, see how it goes. At the moment, we've got it on a running tune at 900 horsepower. So
it's a pretty healthy run-in tune.
So that's you call it your Sydney running tune. Just drive it on the street. Just to dial in the car. Just make sure you get all the teething issues sorted. If there's a little leak here or there. And then, once we're happy with it all and we do a few runs, maybe a few private test day or something, then we'll start putting some more boost in it. So, yeah.
Where are you at boost-wise to make that 900? And more importantly, can you give us a sense of where you expect it to be, both power and boost-wise, when it's all in?
Yeah. So, on E85 fuel, and that's just Bowser E85, we're at 50 PSI of boost, and it made 900 horsepower on a roller dyno. So we're happy with that. It was good numbers, good sign. We want to try with the same fuel, just due to the fact of racing, roll racing, and the rules. Probably try to put 60, 65 pound through it. Obviously, we're happy with the engine. The engine can handle it. The head gasket setup is set up for it. And then hopefully, if we don't run out of fuel with methanol when we want to drag the car, we might, because it's got 8 injectors at the moment, 8 Siemens, we might need to put 12. To run the methanol and probably go up to like 80, 85 pound of boost.
And where do you sort of see it at that sort of boost level with that turbocharger? Can we take a stab in the dark at where you think that power might end up?
We're hoping to get 1500 horsepower. If we can
that sounds pretty reasonable for that combination.
Yeah, 1500 horsepower with that turbo. We see ourselves obviously putting a bigger turbo later, but we just want to get the car out. We started building this car in COVID, so it just slowed the whole process down and things changed over time. So now it's just the goal is to just get it out, run the car, but there's big plans, big goals. We want to break records.
Sure. Now, I've already had a quick look around the car and I couldn't help but notice that there's 2 blue bottles in the boot. What are you using the nitrous for, and how is that nitrous being used? Is this sort of for drag racing, or is it more around the roll racing for the boost response?
A bit of both. Obviously, roll racing is a bit challenging with getting on boost, coming onto the start line. They obviously change it sometimes, so there's different strategies you have to run. So at the moment, it's set up. The nitrous is set up. 1 bottle is for spool, and we can leave it on throughout the rev range, and then we've got a direct shot, 400 shot of NOS through the other bottle.
So that 400 shot is just in case your 85 PSI on its own is not enough to keep you happy.
Yeah. So if you want to, line up next to someone that's making a lot of power and you just want to click the button, it's there. We're not ready to start on the 400 shot, but it's there, set up, ready to go when we're ready to use it.
Okay, fair enough. Let's talk about the drivetrain, because this tends to be kind of the weakness in factory four-wheel drive cars when you start making this sort of power and try and run them down a sticky drag strip. And I've had my own experience of breaking more than my fair share of transmissions. So what are you running?
So the driveline part, honestly, is my favourite part. I probably speak to someone almost every day about driveline, what clutch, what gearbox, and all that. And because I've done so much testing in our car, and I know what works in a big car like this, we just never were able to do it. So now that we're able to do it, we got the green light. We went to a Holinger sequential, just because, you know, it's Australian made, it's Australian support. I love supporting Australian stuff. We knew that we can go paddle shift, which I wanted to do in that car. We've got a triple plate carbon ATS clutch in it, which is, you know, I love those clutches, and we just want to test it in a big car because there's a bit of doubts with, oh, you know, it's more of a race clutch, it's not really a drag clutch. Carbon doesn't really work in drag cars. Well, we want to see what it does in this. I'm confident with it. All-wheel drive system in Evos, it takes a lot to understand them for a lot of people that, you know, haven't really worked with Evos, but we kept ACD in this car, active center diff. We've implemented that in our race car, and I've sort of tried to put it into the drag scene because I could see something that works, and if you can get it to work properly on a launch, then you're going to have traction.
For those who aren't aware of how that Mitsubishi ACD or active center differential works, can you give us a quick rundown on where you see that advantage in a drag application?
So in a drag application, a lot of people with Evos have a viscous setup. So, you know, they're relying on the viscous to lock the front to rear wheel. You know, if it's 50-50, it starts spinning the front wheels too much on a launch, which, you know, you see a lot of Evos in videos, you know, they're burning the tires and smoke coming out of the front wheels. Well, that's obviously going to be slow launch, and your 60-foot times are, you know, all that you need. So our active center diff, we can, through the ECU, through the hydraulic pump, we can lock it 100% lock and say, okay, all four wheels move at the same time. We're hoping that it will hold up, which I'm confident it will. And if it doesn't, well, we can mechanically lock it anyway through that transfer case.
All right. What about the actual actuation of that gearbox? Obviously, you've got the ability to shift a Holinger sequential gearbox manually with a lever or paddles.
Yeah, we stuck with paddles because obviously it's latest tech. You know, it's something that we can control. You know, what to shift and how to shift it and what RPM range we're trying to target. We can also go auto if we want to, which we'll probably do later. But yeah, man, like after driving paddle shift, it's a no-brainer just to go with it. It's better, it's faster, and it's safer.
Now, bringing all this together is really going to rely heavily on the electronics package. So the ECU, the dash, etc. Talk us through that.
Yeah, so EMtron, obviously, we work with them very well. They've supported the car, and you know, we hit them up and said, look, we want the best of everything, and we might go to a 12 injector later. And we've got, man, you know, over 50 sensors in this car, looking at everything. So EMtron got us a KV12, and it's controlling, you know, the ACD, it's controlling the paddle shift, and obviously all the engine package stuff. So yeah, man, we can look at everything, wheel speeds, and you know, even the suspension. We can log through the ECU.
Now, another element that we talked about off camera is you incorporated a drive-by-wire throttle on the intercooler plumbing as well. Yep. Can you talk us through how that works in conjunction with the EMtron?
Yeah, so EMtron's, you know, talked us into putting a second throttle body for anti-surge. You know, it's good for spool, launch, obviously keeping the turbo happy, and the boost up. So we wanted to go with that. We trust that EMtron, you know, all the tech and data and, you know, the development they've done with it. So, man, we said, you know, it's a no-brainer.
Oh, look, it is an amazing car, and it's a credit to everyone who's been involved with building it. Shame it isn't quite ready for a full power pass down the strip, but we certainly look forward to hearing the results when it does hit the strip. So thanks for showing us around the car, Jimmy.
Thank you very much. Thanks, guys. And thanks to everyone that's involved in the car. You know, obviously thanks to HP Academy, you know, EMtron, Micks Motorsports, PRP, everyone that's involved in the car, man. It was a long process. It's a big car. It's probably one of the best Evos in the world at the moment. But yeah, we just got to do some times now.
But as they say, good things do take time.
That's it. Thank you very much.
If you like that video, make sure you give it a thumbs up. And if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.